Hello, my name is Mikhail. I am going to go ahead and do a run through of a patch I built for a recent performance I was in within my coursework, improvising cyborgs, in here at ASU within the College of Arts, Media, and Engineering. My final group, we came up with the title last minute Six Michaels um, as a group improvisational performance with two guitarists, a bass guitarist, a flute, saxophone, and a synthesizer. So I'm going to go ahead and get started. First and foremost, the visuals that you see, I'm going to go ahead and zoom out here. I used a basis of Amazing Mac Stuff tutorial, an amazing channel. I will link the video that I used in the description. The video I used specifically titled Point Cloud with Connections. So that was a really interesting patch that delved into jitter, something I had never really gotten a chance to delve into before, as I've been mainly focused on the audio side of Max MSP. But this has really kind of opened my eyes to what is possible with jitter and some visuals. So essentially what the visuals are doing is just, actually, I can open up the Visual Studio Code here. All of this defines, how many particles each single particle would connect to. There's other variations, some of this is within a loop, so this entire animation will just kind of like consistently be moving around, having these really like chaotic kind of interactions with each other, and the code just specifies, how far away a point has to be from another point for a line to connect to it. In the patch itself, we are actually given the ability to control some of the line frequency. I can't really change that right now just because I have the audio reactive portion activated. So if I did that, increase that line frequency, you see it gets really chaotic. But to balance that out, you can also scale the number of points, which adds a really cool effect to it, making a lot more close together points, adding more, almost looks like adding polygons within 3D animations, but it's kind of a 2D plane. So that adds some interesting effects to it. Our audio reactive portion of it allowed for us to have a more immersive experience for the not only the viewers but the performers themselves, as they can see the corresponding line frequency as they increased gain or increased volume. The way that is done actually is this takes the input from computer audio and it runs it through the bonk object, which I have the help file open for. But this utilizes bonk to find the attacks within incoming audio. These signals are then scaled and implemented to have visual elements correspond with audio in real time. So this was a really, really fun addition to this patch that added for a lot more kind of immersivity. So this goes through. I scale it to also run it through a slider to make it a little bit less of a rapid change and thing. Also to give my computer a bit of a break. I had to go in and out and really test out what would be too taxing on it, because I ran this off my my Lenovo laptop in the actual performance. So a couple other aspects were like just the iterations of the patch. A few weeks prior to our final performance, we had a run through that we were able to get some critiques on. Some of those critiques involved, how long each of the performers had, because we used the visuals as a basis for who's going to take the lead in our ensemble. So each one of us has a preset dedicated to the person performing. So like preset 1. This is going to probably take a little bit to get over here. There we go. Preset 1, preset 2, preset 3, again. Also, just because I was really messing around with it for a second there. And I'm reset here. There we go. 4, 5, and 6. The way each one of us corresponded to a visual, the method we had to change up a few times because before, when we were basing what we were seeing off from a projector into our actual performance, it became a little bit difficult because the projector's lighting might be a little bit different than what you see on the screen, so it might, the translation of it might get a little bit lost on us. Especially it's very hard on the eyes when some of the color presets got very, very similar. So like one might be yellow and then somebody else's might be orange. So my solution to that was to actually change the backgrounds and not just the line and point colors. And that worked pretty well in our final performance. Another thing was within the method of changing the visuals. So I have this set on a timer for 90 seconds. So that's Metro 90,000. Before I was actually using a table object, which really gave us problems in our first run through because the table object decides things based on probability. Kind of get that in here. But you'll kind of see why we didn't want to use this. So you can decide based on the XY axis. So this would be like the likelihood some preset is going to get. We'd run it through the selector and preset object. But the probability from like a scale of, I think I set it to like 1 to 24, which really didn't work out because somebody's visual might be on the screen for like 5 minutes straight, and then another person's might be up for, not even a minute, or might not be up at all, because of course we can't take hours and hours to run through just one performance. So what I did, I actually used an earn object, which cycles through at random through each one of the presets and does not repeat. It only goes through once. And that was a pretty good solution for what we were trying to accomplish. So everyone got their turn to really take the lead in our ensemble, giving each one of us about 90 seconds. I think we actually went over the estimated time. By the end of the performance, we were a little over 11 minutes, which actually ended up great. We kept that momentum going. One of the first iterations of our performance, we really lost steam about halfway through because we realized, oh, these visuals aren't changing, or somebody might be lingering on their visual for like 2 cycles. So, somebody might get like 4 minutes, like I was saying, on one visual. So they never stop taking the lead, and then everybody else has to wonder what is going on, and then we get confused, all that. So also to describe a few other things going on in the patch, this all was actually not implemented in our performance, as you'll see with the video I link in the description. This was meant to actually replace or put in a drum check. I know I have it set as pad 2, but yeah, we're going to use just a drum loop or like a drum sample and have that run through and have that kind of be the tempo basis for our performance. But we actually strayed away from that for the reason of honestly just ease of access. We had our other performer on synth using VC Rack 2, I believe, and if you were to use a sequencer, things would start getting really out of time. If this is going at one consistent tempo in a sequencer, it's just hard to line up. So we decided to take that and go a little bit more of a freeform route. So we actually didn't use anything tempo-wise. We didn't use anything scale, chord, or key-wise. So it became really freeform, and the focus really switched to everybody corresponding with their own visuals. The audio reactivity helped with that, at least in my opinion, a bit, because I could kind of gauge my volume, really playing with dynamics and stuff really helped a lot with the performance, as well as just balance. So we could really, since we had a really interesting ensemble like instrumentation, It's not often you see this combination of instruments put into one band. That gave us the opportunity to really just hone in on, one person takes the lead and the rest of us kind of follow suit, really just focus on how we as individuals can balance behind or add on to the performance. So that is pretty much the entire patch. That's just about everything I wanted to cover. Some of the other things I added was just the movement that you see in the camera here. I can go ahead and just kind of like deactivate some of these to stop it from moving. Because another thing that we were like really wanting to do with minimal interaction from the performers, so everyone could really just focus on their instrument. Nobody had to sit there with the max patch and adjust things as time went by. These all control the panning of like this lens, so these would connect to like the JIT world, the JIT camera, stuff like that. So you get that window to pan to and from, and I had this all full screen, so earlier you may have seen that the visuals kind of went off screen for a while like that. So having the entirety of my screen to really play with, so the boundaries would just follow, kind of go off screen just a tiny bit, but still have the visuals visible to the audience and to the performers. And again, that was helped from the performer standpoint just by basing our leads off of the backgrounds instead of what's going on with the lines and all this. But that's just the long way of describing what is going on here. But yeah, so delving into the jitter, this was just like a really awesome opportunity, especially for me, just to kind of get some experience under my belt when you, especially the ease, when you just right click on one of the inputs and then you just get this list of attributes that you can just add in there. So of course, a lot of these aren't kind of relevant to what's going on here, but some are. So when I start delving into the color and stuff of the backgrounds or the lines and the points, that's where my custom ability and the interactivity really came in. So that is about it. I am going to go ahead and post all of the links in the description. I'm going to post the patch itself to my GitHub page, so you can download this yourself. If you want to look over it's what's going on, if you want to use it as a basis, please feel free. Definitely check out the tutorial from Amazing Mac Stuff on YouTube and credit them, because that is just an amazing resource, especially with how many tutorials are up online for free. So that is an awesome learning tool there, and that is about it.